When it comes to quantum physics, quantum means quantized, which means integers, which means the energy is at discrete levels. What we want to do is we want to make sure everything's in SI units. Let's now think about plugging into this equation, and we'll see if we get a nice pattern. So notice we now have our answers. That's today on High Peak Education. Investigators have created structures consisting of linear chains of ionized atoms on a smooth surface. Electrons are restricted to travel along the chain. The energy levels of the electrons match the results from the particle in a box model. For a 5.0 nanometer long chain, what are the energies in electron volts, that's EV, of the first three states? So hopefully you understand that when it comes to quantum physics in elementary modern physics, quantum means quantized, which means integers, which means the energy is at discrete levels. The idea is that for an electron in a one-dimensional infinite well of length L, so we've got this infinite well, but the length across the electron in the box, so to say, is length L, we have this equation for the energy levels. Notice it has a subscript n because n is the integer. N is a positive integer. 1, 2, 3, and so on. And it's going to be n squared h squared over 8 mel squared. So that's the integer squared, Planck's constant squared, 8, and then mass of the electron goes down here, and then the length of that box squared. And then this is the so-called restricted along the chain one-dimensional confinement. What we want to do is we want to make sure everything's in SI units. So let's convert, first of all, the length in nanometers into meters. Nanometers is 10 to the minus 9. Then all those constants I mentioned, Planck's constant, mass of electron, and then electron volts are all shown here to 4 decimal places of accuracy. So these are all in SI units, joules times seconds, kilograms, and joules. Let's now think about plugging into this equation, first of all with n equals 1, but then 2 and then 3, and we'll see if we get a nice pattern because the only thing that changes is the positive integer n. So plugging in n equals 1, we got 1 squared h squared over 8 mel squared. We're going to go ahead and set up these constants, plug those in. We get that the energy at level 1 is about 2.4099 times 10 to the minus 21st joules. Let's convert that to electron volts. We get about 0.0150 electron volts. Now, the calculation for the other two levels, in other words, level 2, n equals 2, and level 3, n equals 3, it's going to be the exact same, except that we just changed the n. Hey, thanks for watching our content here in High Peak Education. Please hit those comments down below this video and let us know what other kinds of videos do you want us to make. Thanks for your engagement. We appreciate it. Let's get back to today's video. So when changing the n, we've got 2 squared or 3 squared. But notice that it's just going to be a constant multiple of that previous energy that we just found. So it's going to be 4 times E1 is E2, or 9 times E1 is E3. So we can even multiply the final result, which was in electron volts, to get the final result for E2. So we get about 0.0602 electron volts. And then for energy 3, we get 0.1354 electron volts. So notice we now have our answers. The pattern is going to just go as n squared, however many levels you have. So 1, 4, 9, you can imagine level 4 is going to be 16, level 5 is going to be 25. Those are all the perfect squares of the positive integers. One last thing I'll say is that a longer box compared to L equals 5 nanometers is going to give smaller energy spacings. So in other words, back here, L is increased, then we're going to have a smaller value of the initial level 1 energy, and so there's going to be less spacing between the energy levels. And that kind of makes sense because when things are more macroscopic as opposed to quantum scale, when things are long, the energy tends to be a lot more smeared out, and we can't really tell the distinct levels of energy in terms of the distinct quantized energy levels. Thank you very much for your attention, and thank you for watching High Peak Education. Please smash that like button if you enjoyed this content. Subscribe to the channel to grow the channel. Social media links are in our description below. We appreciate your time, and I will see you in the next video.